Hello guys, I want to give you an overview of my Kay3D Labs Ender3 CoreXY conversion that I put together. I bought this back in the pandemic in 2020 and eventually put it together in 2023. Now this is the CoreXY conversion for the Ender3. There was also a conversion kit for the Ender5, which is a bit easier modification since you already have the frame available. As far as some of the specifications on this frame, the external side dimensions are X is 400, Y is 330, and the Z is quite tall at 590. The inner frame measures out, the internal frame measures out at 360, X and Y is going to be 290. So this makes the build plate size a little bit smaller than expected. So the build plate size is 235 by 235, but as a result of all the frame dimensions, the X retains the 235 dimension, but the Y is reduced to 205, and that basically is due to the shorter bar here and the contact with the hot end and the front plate there. In general, what I learned is if you're designing one of these, you roughly need about 125 oversized on the plate for the X, and the Y needs an oversize of about 115 oversized past the plate on the internal frame size. So you have full use of the frame there. So some of the features about this is it's all metal system. So a lot of the printers out now, you can do 3D printed designs, but this is all metal. So all your carriers here, top and bottom, and on here, and also down the bottom on the Z is all metal. So less creep, more rigidity. Power supply right here, and also the stock board. You can run Marlin or Clipper if you have a Raspberry Pi. And then there's a screen mount option. I've since modified this design. So this is actually the Y side. It's just easier getting access to it here and turning the power on rather than getting access from the front here and getting through all that stuff. So originally the screen was down there in the lower right side, and then you have to reach all the way over to the back side here to turn it on. So I just found it more convenient to kind of shift everything over to the Y side. So about Kay3D Labs, they were a company based in Singapore and it has since gone out of business. The Facebook page is still up. The first post was in January 2020 and the last post was in January 2021 with a notice about shipping out the Ender5 kits. There's no comment about closing shop. Unfortunately, the main guy that was running it all was Alvin, super nice, friendly guy, big heart, a lot of brains. It seemed like he saw that the Ender bed slingers could be modified and converted over to a CoreXY system for faster printing. So he saw like, hey, all these cheap Ender5s out there, or Ender3s out there, could get replaced. It was a great job for a DIYer who was interested in doing something like this. The Facebook group is still out there. There's two, one for Kay3D Labs, and there's also a Kay3D Labs user group. In there, you'll see many postings for the Ender5 conversion, not so many for the Ender3 conversion. I also question how many Ender3 kits were actually manufactured. There's just not a lot of information on them online. Kay3D Labs also has their YouTube channel. They have a video on belt routing, belt alignment and tension, and also the Cheetah 5.0 conversion. This is how actually I found Alvin originally, was for programming Marlin and upgrading my board. So from there, I just followed along and he started advertising these conversion kits. So I was like, cool, let's go ahead and do one during the pandemic. Teaching Tech also did a review of this conversion kit. There's 290,000 views of this. So it's interesting that it has a lot of traction. Unfortunately, things didn't go so well. The company's website has since been removed. There is I do have a copy of the manual on a Google Drive. I can provide that in the link below in case you're interested to understand how this thing is assembled. I do recall Alvin said he had some issues with sourcing quality parts from the various vendors. I think that's probably a pretty big headache as far as getting consistency and quality to your customers. And as far as another concern about all this is the overall price. At the time, it was a bit steep, and I was like, let's go ahead and do it. It was $329 for the kit, and the international shipping from Singapore to Thailand at the time was $99. And then I had to pay $60 for import duties. So that was $488 total. And then you have to throw in the price of the Ender kit, which is about 120 bucks at the time. There was a lot of feedback online about, hey, just buy an Ender3, but also, hey, that's also not a CoreXY. So if you look at 550 bucks in today's market, you can actually get something pretty good. From Bamboo with an AMS system and super fast speeds. So it's kind of hard to compete in that market space. There are still a lot of other DIY Vorons out there that guys like to build. So this is definitely for a printer system that for people that enjoy working on printers rather than just printing themselves. So what's in the kit? Well, we borrow 7 of the 8 rails from the Ender3. The only one that's not used is the X gantry rail. Everything else is repurposed into this kit, and the kit comes with 10 extra rails to complete the assembly. So there's 17 rails in this entire thing. So if we look at going from basically from the bottom to the top, the bottom is all original parts that were taken from the kit. So these are the 2 base pieces there, and the front and back are your vertical Z's extrusions that you used. And then the other parts that we stole from the Ender kit is this rod right here that supports the bed. That was the old bed support for the Y on the old kit. The transition bar from the 2 main bases goes right here, and that basically just mounts the control board on there. This kind of piece is kind of optional. You could build something completely different and utilize it, but it was a good use of the the material to package everything nicely. So if you look at the parts that we actually need to complete the kit, the 10 items, there's 4 vertical bars that go around. So those are 20 by 40s that go around the outside. And this top frame is all new. So these are 2020s, the 4 pieces up top there. And then these bars right here on the front and on the back, those are also new to the kit. So there's, some you're basically getting half new and having get half reused parts to help build the frame. Okay, we also got a whole box of parts that came in the kit. Also a cool little letter here from Alvin. Thanking you for your support for purchasing the kit. That was a nice touch. Whole bunch of parts. They got some extras left over, but everything was nicely bagged and tagged, so you knew where to put everything. So the metal top end parts, as I said before, it's basically a series of 4mm bolts running through. They're either holding studs and then T-nutting to the T-nutting inside of the extrusion, And then here we hold the pulleys, either a geared pulley or a bearing pulley. There, the internal height of this is about 22 millimeters. So as you can see, there's like just like a series of spacers that go in there to make it all work. So same with the front here. Idea that we got metal spacers and the top and bottom plate that gets put into position to help secure everything. So if you look at the gantry, it runs on V rollers. It has a custom top and bottom plate again, using again the top bar from the Ender3 kit. So this kind of moves back and forth smoothly. So the belt path is like any CoreXY machine. There's a top belt and a bottom belt. So the top belt runs from the hot end gantry up over here to the front, to the back, and then it runs on the bearing over here, runs all the way over here, and then it snakes through, and then back over here, and comes straight out, back here, and then to here. So it's a mirrored situation for top and bottom, but quite clever to make it all work like that. All right, changing sides over here. You can see how the Z works. Down here in the bottom, we got our Z stepper, and then we have a bearing. This is a closed belt that runs over here to this Z rod, and the other Z rod over there runs around. And if we move around here, you can see we have the two Z rod linear rails there, linear rods there, and then the Z rod here. These are roughly 23 inches, I recall. So this moves up freely, sort of. I'll talk about that with my issues later. But it's a pretty good design. One modification I want to do is to re-drill the plate in the hot end support and rotate the 2040 flat. So that's going to give me an extra 20 mils of build volume, and the build volume is already pretty big as is, but you know, just for fun, right? So keeping on with the Z-rod system, for some reason the front side, you can see that the offset here is quite tight between the mount and the rail. If you go on the back, the offset from the rail to the rod support holder is quite big. I think it's about 17 mil difference between the two. I really don't see a need for that. Yeah, it keeps some space here, but there's space that you could absorb on both sides and just run the same narrow thinness of the Z-rod supports. So we can go with just to a shorter one there. So for the end stops, ironically, I just upgraded to essentialist homing last week, but the end stops used to be here for the X, was mounted here on the gantry. And so when it came in, it would hit there. And then the Y, there was a mount here. So as the gantry came back, it would click. I still use the Z is still here, which I've since upgraded to a probe mount. But the Z would go off of here and then click the Z switch. All right, so with the control box here, Kay3D Labs provided some extension wires. One for the screen, since the screen was mounted all the way over there. And there's also some extension wires for the stepper motors here and there. I think they had to change one of the Z's to the B and things like that. It was a bit confusing, but it all worked out in the end. So some extension wires are in order. And the spool holder is mounted off on the backside. The Bowden system used to be right here, I believe, and then would pump up. I don't use this too often. You just use a filament dryer and then run straight into the Bowden tube to the direct drive. All right, so the big question is, how fast is this thing? So it's running Clipper, and I was able to use the accelerometer on here. So with this heavy direct drive NEMA 17 motor, X is able to run at 18,000 and Y is able to run at 12,000. And out of curiosity, I took the stepper motor off and reran the test, and surprisingly, the X increased from 18,000 to almost 21,000, but the Y stayed the same at 12,000. So it's a bit peculiar on why that happened. So all the corners have printed supports. Every angle gets a support with the exception of the top frame. The top frame has an ID support here, or interior support that clips into there. Otherwise in the front, you got a support here, and then we got a support here all the way around. So unfortunately, when I first started putting this kit together, it was really aggravating because nothing was lining up. And going back and looking at it, the reason why I have printed supports is the supports that came with the printer are not at true 90-degree angles. So you can see there's a slight hair of space there between the two of them, and they're pressed down the bottom. So that little distance caused all the angles to come in, and I was just fighting it the entire time. Even if you look at the video of one of the 3D printers on YouTube, you'll see that the corner angles don't line up, and that's because these brackets are bad. So that was one thing I had to fix. So one of the issues I had with this printer is that there's a lot of Z wobble. You can see there at the top of this print, cylindrical print, there's a lot of Z wobble on this. It kind of starts after 25% through. Bottom part's okay. So I struggled with this, and it was not, I measured everything, used all the jigs, and even tried the different pome nuts and then the anti-backlash things, and still having issues. And when you raise and lower this, you can see that these guys will start to vibrate back and forth as it gets lower. So there's some interference fits there. So I have a plan to go ahead and modify the system to a Z-belt, which I found extremely reliable on my CR10s. So I'm looking forward to do that. So just review some of the upgrades I made to this system. The first one is the direct drive. I made a new fan system. This one's more suitable for PETG. So you can see there that the hot end actually sticks out. Where the original Creality one, everything was enclosed, and so your cooling fan for the hot end was actually blowing onto your part. So this was just a better way I found to keep the part from cooling off on you. Running a BIQ mini micro probe. As I mentioned earlier, I am running the Clipper. I highly suggest Clipper. It took a little while to get it up and going, but it's definitely super easy for making mods versus running Marlin. So I really enjoy that. So some of the updates I want to do, again, I want to do the Z-belt on this, and I have those parts designed and printed. So hopefully there'll be a video out later on that. Also, I want to do a better XY tensioner. At the moment, you go through a process of just pulling the belt tooth by tooth to get it to tighten it up. And I'd just like to have a bit more fine-tuned adjustment. There is a plate here, adjuster plate, to move the motor. Haven't really played with that. It just seemed a bit awkward to tighten it and also screw down all 4 screws at the same time. So another option I want to do for upgrade is linear rail systems. I have the linear rails for the X and the Y, just to see if we can get more speed out of the system. So another upgrade I want to do is the power supply. Instead of it hanging off the side, is I want to go ahead and translate it to relocate it to the back where the Z stepper is currently sitting. And the final upgrade that I want to do, pie in the sky stuff, is I have a Kraken board and a 48-volt power supply, and convert the top end all over to the Mercury 1.1 all-wheel drive system. There's files out there to print, so that would be an option. So as a kind of an overview for this whole thing, that original YouTube video from Teaching Tech, I mean, he said it was a very well thought out, engineered system. It is really for the DIYer that likes to tinker. I completely agree. I've enjoyed playing with this and making it work, trying to make it go faster. So would I do this again? You know, I am looking for a Ender3 to try to do a Mercury 1.1 update on that, just for fun. See whatever happens with that. So this was a conversion kit for the Ender3. Looking online, there's a handful of Ender3 conversion kits out there. The Fabrico Ender3 NG version 1.2. There looks to be maybe a clone version out there for a little bit cheaper. There is a video on YouTube where a guy spent 110 bucks and converted an Ender3 to CoreXY. There's also the Ender3, the CoreXY Ender3, the Do Ender on YouTube, and likewise the Mercury 1.1, which you could, use the top end parts and the whole system there to modify it. So overall, great little project. It was fun. Some headaches along the way, but that's part of the excitement of building printers. So hopefully you found this video educational, just to see how a conversion can be done and make it all happen. Thanks, guys. All right, so here's the homing process using the virtual end stops with Clipper. Set at a relatively low speed to ensure that the amperages are met when it slams into the rail softly. There we go. There goes X. Here comes Y. There goes Z. And here I'll show you the Z rod. I mean, that looks pretty stable for both of these guys.